in this problem we have three binomials. Each binomial means something. Each binomial has coefficients and variables. First we will need to start adding the first two binomials. So it would be 2x equals 4y, and as we can see we have here two negative signs. So whenever we have two negative signs, it will be positive. Plus 5x plus y. Remember, you need to always make like terms. In like terms, you will need to add everything with the same variable. So in this case, we will add 2x plus 5x. It will be 7x. And now we have a negative sign, so it would be a subtraction. Now we have the first answer from with the other binomial. So it would be 8x, this binomial, plus 7y. And it is an addition, so it would be 15x plus 8y.
So hello, good morning, and right now we're seeing the next problem, and my name is Sebastian, and what we can see here is a simple multiplication of a polynomial, and what we need to do here right now is pretty simple. So we can see that the whole expression that is over here is going to be multiplied by this expression. So what you're gonna do here is right now is multiply this times this times this, and this times this. So if we like just multiply the same coefficient, it will be like 7 times 2, which give us 14. But then we have the variables, and the variables, if you remember, they have a rule that says that when they're multiplying, they add themselves. So if you have a times a, and we can see here that there's one imaginary symbol that says that is elevated to the power of 1. So what you're gonna do here is multiply a times a, which will give you a to the power of 2, because you're adding them. So b, there's nothing here, so just write them down here like b to the second power. C, you also have a imaginary 1, so c to the second power. We have a negative, so we write down the negative sign. Then 7 times 6 gives us 42. Then a times a to the second power, you just add them, so it will be a to the third power. Then b times b to the third power and b to the second power. Add them up, 3 plus 2 equals 5. So b to the fifth power. Then c to the c times c to the second power. You use animal 2 plus 1, it will be 3, so c to the third power. You add the plus sign because you continue. 7, it doesn't have any coefficients, so you just put it up over here. Then we have a1 and a minus 1. So in an expression, it will be like 1 minus 1. So it will give you 0, and if it's a 0, there's no variable. Continuing, b to the second power minus b to the second power, it cancels them out, so it will be 0 also. C minus c1, so you're multiplying, it will be subtracting, so it will also give you 0. So the expression will be like this, which is 14 a to the second power, b to the second power, c to the second power, minus 42 a to the third power, b to the fifth power, c to the third power, plus 7. Right now, I'm going to show you some common mistakes that can be made in this process. So, if you saw, first of all, we need to talk about the variables. So, we can see that a times b to the third power. We have this, and then maybe, I don't know, a to the second power times b to the fourth power. One common mistake is that people sometimes don't realize that over here is a 1. So, what they will put here, which is incorrect, will be a to the second power times b to the 7th power. But it's incorrect because, as you can see here, we have the variable with the 1. And the correct answer will be a to the 3rd power times b to the 7th power. So this will be the equal. That's one common mistake. Another common mistake is that sometimes you make the parentheses first. I don't know, maybe we have 3a to b to the 3rd power plus 7a to the 4th power b to the 3rd power. And sometimes, and I don't know, 14 over here. And sometimes you just think that, oh, I can add them up. But you can't, because they don't have the same coefficient. So they're not the same expression. I know maybe you're saying like, oh, maybe we can do PEMDAS or stuff like that. But no. When we're talking more about variables and we're getting more like deeper into that stuff, we're forgetting PEMDAS and start doing this. So the correct answer for this one, you just multiply this times this and this times this. Simple as that. Now, let's get on to the next problem.
Now in this problem, we need to factorize. We can see there is coefficients and variables. Each fraction means there is a coefficient, so we have 3, and we need to factorize from up to down. So in this case, we will apply the parentheses or distributive property, such as x and parentheses to give these all fractions. So it would be in this case, from up, we can see there is a factor, the common factor from up is 5. And from down, to be easy, it would be 1. So the fraction would be 5 and 1. We can see each coefficient has its own variable. It is a and b. So the least variable with the least number of exponents is a3, so it would be a3. Now, this is the distributive property. Now we're going to start doing the parentheses. We need to see which factor is from up. Now from 30 it would be 6. 6 and from down 4. In exponents we can see these are the same, so it would be 9. Now from 40 we got 8. And from down we got 7. Now the exponent is coming here. What we need to do with exponents is to subtract. 7 minus 3, it would be a 4. And from 15, now we got from the next fraction, it would be 15, 3 and 8. The exponent would be a1, and as b, there is no other b, so it would be the same, b6.
Now let's check this problem. We have x to the second power minus 25 over x to the second power plus 9x plus 20. So for simplifying this, as you can see here, we cannot put or write down right now like, I don't know, 5 or x, because they don't have a common number, a common variable. So what you're gonna do here is just write down into a simplification that will be like this: x plus 5, then let me do this bigger, sorry, x minus 5. Why am I changing the symbols? Because as you can see here, as before told, you multiply this times this. Let me show you. This times this and this times this. So we multiply x times x and x times negative 5. But the symbols, I write it down like that because there's a negative over here. So the answer obviously will be this, because x times x is x2. Then x times 5 is equal to negative 5. Then 5 times x equals 5, which will be 5 minus 5x equals 0. Then 5 times negative 5 will give you 25. Next off, we need to do the same, but now over here. So we're going to write down x, because they're all positive over here, we can see positive, positive, positive. So you keep the same symbol, plus. Now what we're gonna do here is understand, like, this need to be, let me write it down here. You just need to multiply the x, in here you just need to add them up because of the x, and in here you're going to multiply also. So we need to think of two numbers that add them, by adding them up gives you 9, and by multiplying them gives you 20. So let's start with, so we can think of two numbers, and let me guess, like a 5. So 5, then, so 5 plus what gives you 9? So you use 9 minus 5 gives you 4. So what you're gonna do next is write down here 4. And as you can see here, if we continue, you can see that x times x gives you x to the second power. Then 5 times x gives you 5x. X times 4, 4x. If you add them up, it gives you 9x. Then 5 times 4 is 20. So now we have the expression x plus 5 times x minus 5 over x plus 5 or times x plus 4. So we just need to cancel out like two common factors, which will be x plus 5, because you're going to cancel x negative 5 and x plus 5 because they will have no sense because of the signs. So you just cancel this out, and then it will give you x minus 5 over x plus 4. And that is the answer for the simplification of this, which will be like this. So let's continue with another common mistakes that were made during the process of the previous problem. One was that we had x2 minus 25 over x2 plus 9x plus 20. So you might say, oh, but we have x to the power 2 and x to the power 2 the same, so we can cancel it out. But that's not correct, because then you will die. Well, literally not. But you cannot cancel coefficients like that, only if they are multiplied. I don't know, maybe we have 5x and stuff like that, 5x, stuff like that. Then we can cancel this out, and the answer will be this one. But only if multiplied. Another problem is that sometimes, you know what, we have x2 minus 25, x2 plus 9x plus 20, is that you don't know how to simplify. So it is pretty easy, so you just have to, like, maybe you will say, oh, x times something and something, but no, because then you don't have an x here, so you need to know how to make the multiplication of a perfect square, which is pretty simple. You just need to check a number that is multiplied, a number that is added or subtracted, and just the x. And also, by law, check the symbols. And that will be it.